This is part three of lecture number 9, and in this lecture we're going to finish up problem number 5. Okay, we want to find the integral of this function. So this function, we want to do the partial fraction decomposition of the function. So this is irreducible repeated root or repeated factors. So we can decompose it as follows: a of x plus b over x squared plus 4 plus c of x plus d over x squared plus 4 squared. We multiply both sides of the equation by this denominator, so then we're going to get x cubed plus 1 equals to ax plus b times x squared plus 4 plus cx plus d. So that would be equals to ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. So here I have here I have x cubed plus 1. So this is x cubed plus 1. So I'm going to say a it's equals to 1, because here I have ax cubed must be equal to x cubed here. That means a is equal to 1. D is equals to 1 also. D here, x times x raised to the power of 0, and then 1 times x raised to the power of 0. So D is equal to 1. 4a plus c equal to 0. That means c is equals to negative 4. And then bx squared. I don't have x squared on this side. That means b is equal to 0. Okay. So that means my integral is going to look something like this. Integral, the first part of the integral is going to be x over x squared plus 4 dx plus integral negative 4x plus 1 over x squared plus 4 squared dx. Then this one here, that would give me the integral of this part is going to be equals to 1/2 ln of x squared plus 4. So the integral of the second half I'm going to be using, so the integral of negative 4x over x squared, this is plus c here, c1 may be called 4 squared dx. So I'm going to use u substitution. We say u is equals to x squared That's 4. That's 4. So then du would be equals to 2x dx, 2x dx, and then at this time I'm going to have integral. So it's going to be this in terms of u, be integral of 4x times du over 2x over u squared. So x and x cancels out, 2 and this is equal to 2, so that becomes negative 2 du over u squared, and that should be equals to 2 over u plus c2, and then u here, and u is basically equals to x squared plus 4 plus c2. Okay, now we go to this part of the integral, this part of the integral, that part of the integral. So we're going to integrate 1 over x squared plus 4 all squared dx. So we're going to use the substitution x equals to 2 tan theta. That means dx is equals to 2 secant square theta d theta. So then we use the substitution. We're going to have integral. So sorry, we have integral of 2 secant square theta d theta over 16 secant raised to the power 4 theta, and that would be equals to that should be equals to some sort of cosine square theta d theta. I should be doing a lot of steps here, but I made them, I condensed the steps. It's easy to kind of follow through with those. Here divided by 8. So then this is going to be somewhere, so when we do the integration of that is going to be equals to integration of 1 over 8 integral of this, we can express it as cosine 2 theta plus 1/2 here divided by 2 d theta, and then this over all of that should give you something like 1 over 16 tangent inverse of x over 2. That's plus 2x over x squared plus 4. This is plus c3. So we add this to this, and we add it to this one. So and then we will have like the final answer would be something like final answer Answer would be something like this: 1/2 ln of x squared plus 4 plus 2 over x squared plus 4 plus tangent inverse of x over 2 over 16 plus x over 8 x squared plus 4 plus say k. That should be the final answer.